This is the apparatus used for the determination of sulfur dioxide in juice or wine. You can see that it's comprised of three main parts: a round bottom flask, a condenser unit and a pear-shaped flask. Going through it section by section, the round bottom flask is at the base, followed by a neck that connects the condenser to the round bottom flask, and above the condenser we have a bridge of glass that goes over to the pear-shaped flask. Off the pear-shaped flask you can see another hose which provides the suction to drive the apparatus. To begin the experiment you first have to separate the pear-shaped flask from the apparatus. This is done by removing the suction inlet tube, followed by the small metal clip that holds the bubbler for the pear-shaped flask to the glass bridge. Note that the clip is usually placed on the tubing of the glass bridge to keep it out of the way. The pear-shaped flask is then charged with an approximate dosage of 0.3% hydrogen peroxide solution. Since the volume is not absolutely critical, it can be done using a non-accurate Kipps apparatus. To use the Kipps dispenser, first tilt it backwards so that the reservoir is filled with the solution to be used. Next return it to the upright position and any excess will fall back to the dispenser. The approximate volume of 10 ml can then be poured into the pear-shaped flask. Since this procedure requires an acid-base titration, a few drops of indicator are added to the pear-shaped flask. Now we're ready to reconnect the pear-shaped flask to the apparatus. Ensure that the glass bridge is reconnected correctly to the pear-shaped flask inlet. Don't forget to put the metal clip back on so that the connection is secure, and then reinsert the suction tube. Next we need to get the airflow right for the aspiration part of the experiment. Turn on the vacuum tap on the bench so that air begins to flow through the apparatus. It's critical to ensure that the airflow rate is within operational boundaries for the experiment. Here you can see that the flow rate is too high. When the flow rate is too high, the sulfur dioxide can actually be sucked through the pear-shaped flask through the hydrogen peroxide solution before it has a chance to react. If the flow rate is uncorrected, the measured SO2 level will be much lower than that is actually in the sample. An acceptable flow rate is achieved when air is coming out of 3 or 4 of the holes in the bubbler tube. Since an acid-base titration is used in the procedure, the indicator has to be adjusted to its midpoint between its acid and base colours. The methyl red methylene blue indicator used for this experiment has green as the base colour and purple as the acid colour. You can see that the hydrogen peroxide solution in the pear-shaped flask is green, which means that it's still basic. I've just added a few drops of a mild acid marked for indicator adjustment, and now you can see that the solution displays the purple colour, which means that the peroxide solution is now acidic. The mid colour between purple and green is a blue. At this point I've just added one more drop of the mild base for indicator adjustment, and you can see that the solution takes on its blue coloration. If I now go back and add one more drop of the mild base, you can see that the colour is changed from the blue back to the green again. At this point, since one drop of either acid or base is toggling between the acid and base colours of the indicator, it doesn't really matter where we start because we're very close to the midpoint. Obviously, however, the best place to start is at the blue midpoint, and so the best practice is to toggle until you get to that blue colour of the indicator solution. So now we have our indicator set up at the midpoint, the flow rate is correct, and we're ready to begin the experiment. Next, we disconnect the round bottom flask from the apparatus by removing the metal clip at the neck, being careful of the central glass tube. An exact measure of 20 ml of wine or juice solution is required for the analysis, and so a 20 ml volumetric pipette is used. Ensure that you're very careful in putting the pipette pump onto the end of the pipette. Next, discharge the 20 ml of wine or juice solution into the round bottom flask, noting that at the end of the delivery the pipette is angled against the side of the glass to ensure that the last amount of solution runs in. A solution of orthophosphoric acid is used to acidify the solution that's being measured, and so drive the equilibrium to produce the gaseous molecular SO2 form. Since neither the volume nor the concentration of the orthophosphoric acid is critical, a KIPS dispenser can be used. Note that once the acid has been added to your sample, it must be reconnected to the apparatus fairly quickly to ensure minimal loss of the molecular gaseous SO2. Don't forget to use the wire clip to hold the round bottom flask onto the neck of the apparatus. Note that the airflow, once adjusted to the correct level, has not been turned off in the interim. At this point our experiment has begun, and air is being sucked in through the inlet tube and is sparged through the wine or juice sample which has been acidified. The gaseous sulfur dioxide is then driven by the airstream from the round bottom flask up through the neck. The vapour then continues up through the condenser, through the central coil, out the top of the condenser and into the side of the glass bridge, across the bridge then down through the bubbler inlet of the pear-shaped flask. When the gaseous sulfur dioxide contacts the hydrogen peroxide in the pear-shaped flask, it is oxidised to sulfuric acid. The presence of the sulfuric acid then causes the indicator to display its acidic colour, which in this case is purple. The reaction between the sulfur dioxide and hydrogen peroxide is very fast. Nevertheless, if the airflow rate is too high, some sulfur dioxide can escape before it's trapped. The aspiration is continued for between 10 and 15 minutes, so around 12 minutes is a good figure. After that time, the pear-shaped flask is disconnected at the metal clip, but don't bother to turn the airflow off, just leave it going for when we do the next part of the experiment. A burette with titrant reservoir will be set up on the bench somewhere, but first we need to fill it up. You'll see that the tube connects the reservoir to the top of the burette, and so if we squeeze the reservoir, the burette will begin to fill. Generally, the height of the inlet to the burette that you can see here is set so that when it sucks back it goes down to the zero level. But if it's not, just run it down so that it's on the zero level and we can begin the titration. Next, begin adding the titrant from the burette directly to the pear-shaped flask through the arm that used to contain the air outlet. As the titrant is added, you'll eventually go from the purple acid colour to the blue midpoint colour once again. You can see here that the solution looks actually a bit green and not blue, but if we take account of the material that's still on the inside of the stem by lifting it up and letting it drain a few times, you'll see that we end up with the blue colour that we're actually after. Since we've finished our titration, we can now calculate a value for the free sulfur dioxide in the sample. Also, since the indicator has been returned to its midpoint colour, we know that the hydrogen peroxide solution is actually neutral now, being neither acidic nor basic. We can then simply reconnect the pear-shaped flask to the apparatus, noting that we left the airflow on before, so that the whole assembly is ready to go again. We're now ready to measure the bound sulfur dioxide level. Ignite the Bunsen burner using a match, and we're now ready to wave the Bunsen flame gently over the round bottom flask. All of the free sulfur dioxide has already been removed through aspiration, but it requires heat to remove the bound sulfur dioxide. Heating the sample causes it to reflux, so we need to ensure that the condenser water has been turned on at this stage. You can see here that the vapour level is building up inside the neck below the condenser, so the sample is obviously getting hotter. We need to heat the sample to a level so that the vapour does not get through the condenser and is safely returned back to the flask from where it originated. In this way we can ensure that volatile acids such as acetic acid do not make it into the pear-shaped flask and so contaminate our assay. To test whether the round bottom flask is being heated strongly enough, you can touch the apparatus just below the condenser very quickly to see if it is warm. Then it's just a simple matter of disconnecting the apparatus first at the glass bridge as before, and then removing the suction outlet tube, then repeating the titration as for the calculation of free sulfur dioxide. Once the titration is complete, we'll then be able to calculate the bound sulfur dioxide level. Don't forget the solution inside the stem by letting it drain a few times.